All right. Welcome to our Leveraging Signal Performance Data to Improve Traffic Signal Operations webinar. My name is Ayrton Coles. I'm with the University of Tennessee Center for Transportation Research in Knoxville. This free webinar is a collaboration of TTAP, our Tennessee Transportation Assistance Program, and of course, our Traffic Signal Academy here. I would like to acknowledge the Traffic Signal Users Group for helping with the advertising of the webinar. Thank you, Steve Bryan at TDOT. I don't know if Steve has signed in yet or not, but thank you, Steve, for that help. I would also like to thank Southern Lighting and Traffic Systems for agreeing to collaborate with the webinar, and also for their donation of an Econolite Cobalt controller to our Traffic Signal Academy. So thank you very much for that. Okay. So by now, we have all heard of ATSPMs, right? Most of you are probably familiar with it and know its fundamentals. So the idea for this webinar and for several others that we are planning for in the near future here is to shift the focus a little bit. Go from learning what ATSPMs are to learning how agencies are incorporating this data on their workflow and how this data is being used to actually improve traffic operations. Okay. But before we go there, let's do some housekeeping. Let's go over some housekeeping items as folks get signing in here. So the first thing I'll need you to do, all right, we already got your registration. So what we'll need you to do is to go to the chat box and please sign your name, your full name in the chat box. I noticed that some of you in the beginning here, you have 2 or 3 folks in the room. So any of you that are that want to get a certificate for this webinar, PDAges, you're going to have to sign in because we're going to match that with your registration. Okay, so please sign in on your chat box. If you're not able to get to the chat box, you can just press Alt-H on your computer or laptop, and you should be able to reach that, okay, the chat box. We are asking for you to avoid using your camera during the presentation. I'm going to shut mine down in just a little bit here. Unmute your audio or use the chat box to ask questions. Regarding questions, we have some time allotted at the end of the webinar for questions. So if you'd like to ask a question during the presentation, go ahead and put it there on the chat box. But I will probably just be touching on that and answering that at the end of the presentation. Okay, so that's the plan for the questions there. A PDH certificate, like I mentioned to you, will be sent for you folks that have signed in and registered within the next 2 weeks. It's probably going to be less than that, but again, we'll be sending you the PDH certificate. And since you are here, you probably should have received an email that we sent out yesterday, and some folks actually signed in, registered this morning, so I sent that out as well with the link to download the material that is going to be presented here. Okay, so you should have that information. Let me go ahead and turn off my video here. Presenters. So again, thank you, Mark and Bill, for presenting here with us here. So let me just go and introduce them. Mark Zinn, ITS applications specialist. So Mr. Zinn has been involved in the traffic industry for over 27 years. His career includes working for Intersection Development Corporation, Peak Traffic Systems, AECOM, Econolite, and currently he is responsible for all ITS products offered by Southern Lighting and Traffic Systems, headquartered in Georgia. He oversees project management, coordinating with agencies, and providing updates on equipment deliveries, integration, and project progress. He's also responsible for configuring and installing the Centrax ITS platform. Mr. Zinn holds a Bachelor of Science degree in economics from Arizona State University. He is an associate member of IT and IMSA and is a level 3 IMSA certified. Mr. Bill Litson, sales and support specialist. Mr. Litson has been involved in the traffic industry for over 30 years. Mr. Litson began working for the Indiana Department of Transportation in the Traffic Signal Division. He has also worked for Econolite and is currently with Southern Lighting and Traffic Systems as the sales and support specialist for Tennessee. He has been factory certified as a Centrax technician and has vast knowledge of Econolite controllers and cabinets. Mr. Litson has taught IMSA classes and provided training sessions for Econolite. Okay, so I see we have about 67, 68 participants now. Please go ahead if you have not done so yet, sign in your name on the chat box. And with that, Mark, let me see if I'll go ahead and unmute you or ask you to unmute, or you can just go ahead and unmute yourself, you and Bill, and I'll stop sharing and I'll ask you to share your screen, Mark.
Okay. All right. Thank you, Ayrton. First of all, I'd like to thank everybody for attending this webinar today. It's an honor to be in front of you guys. I've seen a lot of names on the list that I recognize. So welcome on board, and we'll get started. If anybody has any questions, please put the questions in your chat, and Ayrton will manage those and let me know if there's any questions that pop up while we're doing this.
Hey, Mark, I'm still not seeing your shared screen there.
Is that it?
All right, looks like it's popping up. Thank you.
Okay. So we'll go through just an introduction to the ATSPMs, a little bit of the agency operational objectives. I know everybody has a few different objectives that they're concentrating on, but the example that we're going to show today pretty much covers most of those objectives. Go through a little bit of the traffic signal infrastructure upgrades for SPMs to work rather well and most efficiently. You're going to need to really concentrate on detection. Once you get the detection in place, then we're going to look at the data collection and analysis of all the data that comes in on these systems. With this, we'll look at what is involved in the cabinet and at the intersections for the signal time improvements. And then lastly, we're going to look at how this affects the workforce. Hopefully we'll have a little bit of time at the end of the presentation for some questions and answers. But again, if you have any questions, please put them in your chat box and Ayrton will forward them to me. So what are the SPMs? So everybody knows that the signal performance measures are the hot topic of the day, but everybody always talks about ATSPM. ATSPM is actually a suite of software that was developed by UDOT, Utah Department of Transportation, for collecting all the data, putting it in a visual format that everybody can look at and get some analysis from. But that's about as far as it goes. It just basically collects the data and displays it. What we need is the ability to analyze that data somehow. And before you can get any data back, we have to make sure that we can see what's going on in the field. So the more detection you have out in the field, the better the SPMs are going to work, and the better results you're going to get from them. Most people generally either have no detection or stop bar detection, or maybe some stop bar detection on left turns and advance on the through. For the SPMs really to work well, most agencies are going to need to have stop bar detection lane by lane for each phase on the approach, as well as setbacks in an area of the approach where you're going to have free flow traffic. So we're going to try to avoid any queuing on those detection locations. Once you start gathering data with the signal performance measures, data is going to come in at an astounding rate. We're looking at maybe a terabyte of data every year for a 25 intersection system. So you're going to have also some sort of ability to store the data for not only current situations, but also to be able to go back and look at historical data. The last thing you're going to need is some way, if you're using ATSPMs, some sort of web programmer or developer to help with the software. ATSPM is actually free software that's it's open sourced by Utah Department of Transportation. So you can take it, use it as you want, but as far as developing anything from it, most agencies have to do that on their own. So that's one of the things that is the hardest part of this, is that just looking at the data is easy. Analyzing the data is a little more difficult. Historically, most agencies, when they've been doing some signal timing, do it on a periodic basis of about anywhere from 3 to 5 years. They have to go out and collect the data and then run that data through some sort of modeler, like Vism or Synchro or something like that. They come up with the plans, they send them out to the field, run them through the controllers, and then periodically implement and fine tune. But generally over time, the data model isn't accurate anymore. And you have to go out and rerun another timing study on the approaches. And that's, like I said, every 3 to 5 years. What we're seeing with the ATSPMs is that we have the ability now to actually do all of this in near real time. We can review all the ATSPM data and any field observations that we want to make. And we can run it through a model, and this model doesn't have to be Synchro or Vism anymore. This can be some sort of algorithm or analytics running on the cloud. Timings can be sent down to the controller. We watch and observe the approaches to see if they're working right. Make some fine tuning if we need to, but that is immediately sent back to review. And it's all done again in near real time. For our case, we're looking at about anywhere between 1 minute and 3 minutes to run this whole process. So with the new ATSPMs, we're really getting a lot more efficiency out of the data. Now, data is different than what we're used to looking at. If you look at the raw high resolution event data, it's really nothing that you can recognize. It's not volume, occupancy, speed, detector data that we're normally used to working with. There's event codes and parameters that are, unless you have the code, is unrecognizable. So from this data, though, we're getting a lot more information from the intersection. We're gathering phase color changes, arrivals on red, arrivals on green. We're looking at power failures, split monitor, preemption data, vehicle data, flow rates, a number of things. So we're getting all this data at 1/10 of a second resolution. So it's really coming in fast, which means there's a lot of data coming in. So we need to really figure out how we're going to analyze all that data. Historically, again, we're looking at 15-minute bins on volume and occupancy, easy data to gather and analyze. But with the high resolution data, there's so many more factors that you have to look at that it's just becoming overwhelming for most agencies to even fathom analyzing the data. So with these new approaches, how do we manage and optimize it? We're not only looking at high resolution data right now, but we're also looking at data fusion, which means we're looking at ways to use TomTom data or Waze data or any other cloud-based data that's coming in, crowdsourcing data. All that is available to us now. And as we get more and more of this data coming in, again, it's a vast amount of data that we have to analyze and worry about. So as we move forward, we're just going to look at signal performance measures right now. Purdue University has done a lot of work on developing these signal performance measures, and they've actually turned out to work for us very well. It's allowing us to not only look at the data, but come up with new optimization approaches. So what do we know about this data? First of all, it's extensive and it requires constant analysis. There's so much data coming in. We need to really keep on top of it. But unfortunately, most agencies that I know are typically understaffed. Most agencies, by the IT standards, want one engineer for every 100 intersections. And that's really not out there as far as I can see. Engineers are typically unfamiliar with deciphering this SPM data as well. Unless you have the algorithms and the knowledge of how to deal with the data, it's really hard to try to figure out what needs to be done. Then we look at relating the data analysis to the signal timing changes. How are we going to do it? Are we going to do it on a weekly evaluation? Are we going to do it on a daily evaluation? And then we need all the time and labor to enter these new timings into the controllers, as well as reanalyze any effects that it might have. So again, we're just spinning our wheels if we're not doing anything with this data, but we really need to keep on top of it to make it effective. So as all this data starts coming in, we're just seeing it become so much cheaper and easier to get that we just really have a huge opportunity to work with it. And if we can work with it, we're going to make traffic move so much more efficiently. So moving forward, with the ATC controller hardware that we have out there, the new cabinets, TS2 detection, where we can get above ground detection with one camera looking at multiple lanes, multiple detection areas. We can really start to gather this data and use it. We've done this in Gulf Shores. This system has been running for about 3 or 4 years now. This is a great example for SPMs and how they can be utilized. The population, the federal population is from the census is about 10,000 people. So it's a rather small town. But in the summer, on any given week, it could be 40,000. And if they have a festival, they can see upwards of around 100,000 people through their streets in a single weekend. So they can't really guess when the traffic's going to show up. They can't management on a normal basis. So they really need something to help them out and keep the traffic flowing reasonably well. They have one engineer and he's contracted. He actually does the signal timings for them. And they have 2 technicians that manage the signals and the central software, as well as do all the maintenance on the intersections. So when we started looking at this, there was quite a few objectives that they wanted to consider. First of all, they wanted better coordination. With the fluctuation in traffic and the fluctuation in population, it was hard to maintain a valid coordination plan at any time of the day. With coordination, they also wanted to minimize congestion. Once a week, normally on Sunday afternoons, there's a huge exodus at about noon, where everybody's leaving the condos and heading north. And so it can get really congested. Also, anytime there's a storm pop up, it can go from no congestion to full congestion as people are leaving the beaches. They also have a huge amount of pedestrians, so they needed to focus on pedestrian timings. And with all the coordination plans they wanted to use, they had to somehow reduce the transitions, keep them down to a reasonable time so that they didn't have to worry about spending most of their time in transition. And of course, the heavy seasonal fluctuations. Those are the main 5 objectives that they wanted to focus on. But again, it was probably 8 or 10 others that we really needed to address as well. So in order to get this to work, we had to make sure that we had good Ethernet connectivity between each intersection and that we could get the data back and that it was constant and steady flow of information. The controllers we used were NTCIP. They're ATC controllers with SPM capabilities. Just about every controller out there these days has the ability to record SPM data as long as it's NTCIP compliant and we can grab the data. The cabinets, really no modifications to the cabinets. Any cabinet out there would work as long as we can get the detection that we need back into the controller. Most TS1 controller cabinets that use shelf mount detectors or some sort of in-pavement detection just doesn't have the capabilities to do what we need. So we're looking at using TS1 cabinets with above ground detection that has an SDLC interface to the controller. That way we can do lane by lane detection at the stop bar and get the setbacks on a lane by lane basis as well. Signal heads, the only thing we did on this system was add overlaps where possible. The addition of overlaps really helped move traffic a little bit better and gave us an increase in efficiency. So again, we've already gone over this, but all this data is being collected on a minute by minute basis for near real-time analysis. In most cases, SPM data is gathered maybe once an hour and then used for just monitoring or manual analysis. That's not fast enough for doing optimization or adaptive control on traffic. So we had to really step it up and gather this data on a once a minute basis. Just like in any SPM software, we're using the Econolyze product, Centrax Mobility, and it displays the data just like you'd expect from ATSPM. We have a map view that shows all the different intersections. Not only does the map view show data coming in from SPM, but it also has TomTom data being displayed. Over here, you can see an incident in Orange Beach. And the links up and down the arterials actually show congestion that's brought back through TomTom data. So again, we're starting to look at other sources of data, not just SPM, but some crowdsourcing data and any data we can get from Waze or TomTom. So as we look at this overview, you can also see that it shows ways of efficiencies on arrivals on greens, ped delays, power up times, transitions, and vehicle delays. The higher the number, the more efficient the system is running. And it also has the ability to analyze on its own each intersection and look at hotspots and all the detectors and analyze whether or not the detection is working well. And because detection is so important, this is a really nice feature to have. If you can spot the problems early, you can get them corrected and get back on track. So how's the data used? Again, most people use the data for reporting. One of the most useful reports is the arrivals on green. Everywhere there's a setback detector, you can get arrivals on green, and it really shows how efficient the system is running. Not only for this intersection, for example, I've got setbacks on one of the side street approaches as well as a setback on the left turn for queuing. And it can actually monitor the arrivals on green and see how well we're managing the traffic and reducing the delays. Some of the reports you're going to get from any ATSPM application is, of course, split monitor, volume to capacity, pedestrian delays. You can read the list yourself, but these are the standard reports that all SPM software can provide you. But a lot of proprietary custom software, they go into extra reports. Some of the ones that we use are left turn gap analysis, cycle length analysis, green times. We run an occupancy ratio report, red light running, split monitor. We actually have about 23 different reports that we could bring up at any time for any intersection. One of the nice things about this is there's no more traditional modeling from SPM data. just because we don't gather the volume and occupancy data from each intersection, it's impossible to export that to Synchro or Visum and get a model created for an intersection or for an arterial for that matter. So it's a little difficult to run any type of analysis that way. And of course, trial and error is not an option. We just can't look at the data and make an educated guess anymore. Try to figure out what would do better at the intersections. So developing algorithms with the SPM data is crucial. And what we're using in Gulf Shores is a combination of volume to capacity data, split failures, and a link pivot analysis along the arterial to determine better timings and what we should do with the intersections. The volume to capacity really helps us determine cycle length adjustments. As we approach a higher capacity, it's going to analyze that and consider whether or not to raise the cycle length. If the volume to capacity goes down, then we can start lowering the cycle length back down to a manageable level. The link pivot metric is an offset optimization tool that uses all the detection data, most of the stop bar and advanced, to determine split utilization as well as offset adjustment in order to better manage the intersection. Not only does the link pivot analyze each individual intersection, but it analyzes what effect changes at one intersection will make on another intersection. So it actually analyzes the whole arterial and then continues making adjustments until it can fine tune the whole arterial for the best operation. Addressing the future analytical needs. Again, we need to really assess the performance in near real time as best as possible. Being able to do that will actually allow us to do adaptive traffic control on just about any arterial or any intersection in the city. High level of health and performance of the system. Again, if things are starting to fail on us, like detection or intersections are not working up to what we would expect, we need to know that quickly so that we can make adjustments and get it back up to par. As far as once we get that data, we need to be proactive in our operation and maintenance. So those what we're seeing coming out now is having the ability to have email alerts or SMS text messaging based upon what's going on at the intersection. So if it's starting to fail, we can get on it right away and get it back up to speed. So getting back to Gulf Shores, we wanted to run this in a logical order. So what we began with was starting with level 1, monitoring and reporting of SPM data. We wanted to see if we were getting the data back, what it was looking like, and just start to report and do some basic analysis on it. Once we saw the data coming in, we put that through the algorithms, and we came up with, we have a what's called a pattern optimizer, and it will actually go out and analyze about a week's worth of data. It'll run it through the link pivot analysis and actually come up with new coordination timings for each intersection. And then you can download that to the intersection and watch it run for about another week. You'll run analysis on it, determine whether it did any better or worse. And if it did better, you can run another analysis, and eventually you're going to fine tune it over several weeks to a point where it's running very efficiently and not doing many updates. And once we got to that fine tune, we went and ran real-time optimization, which is an adaptive traffic control, where it's doing it on an automated basis every minute or anywhere between 1 and 3 minutes. So Level 1, again, this was a way to manually evaluate and analyze the signal performance measures just by looking at the reports. So I hope everybody's had a chance to look at signal performance measures. This is the Purdue coordination diagram. This is one of the most visual and helpful tools that we've come up with. It actually analyzes both northbound, for this one, northbound and southbound approaches. Every vertical line here is a cycle. The green is the starter green for the cycle. Then there's yellow and red at the top. That's the end of the cycle. Every time there's a fluctuation, there's a transition. So it could be a preemption. It could be a cycle length change. Anything that causes a transition is going to cause the top line to fluctuate a little bit. Down here, you can see a lot of fluctuations. Again, it could also be the fact that side street had no demand on it, so it never served it. So it stayed on the through approach a little bit longer. All the black dots are individual detection. Again, we're looking at 1/10 of a second resolution. So each one of these dots is a vehicle. Most vehicles we want to arrive in the green band. We don't want to see a whole lot of vehicles arriving while it's sitting on red. So these arrivals on red, these are arrivals on green. We want more arrivals on green than on red, of course. So how do we analyze this intersection? And do we know if we've got adequate amount of time in the cycle length? Here you can see that we're filling up the green band. We might want to consider increasing the cycle length a little bit. Here you can see we've got mostly arrivals on green, so this is good offset. Down here we've got more arrivals on red, a little bit of offset. So we could use some offset adjustment, but again, what are those values that we need to change it to, and how do we make those adjustments? So that's the hard part. So going to level 2, we actually take all that data and run it through some algorithms, link pivot algorithms, as well as volume to capacity analysis on all the data. And we look at that data over a period of 1 week, 1 month, whatever we choose. Once the analysis is run on it, we can actually take the actual data and tailor it for holidays, special events, any type of weather condition we want. Then we take those parameters, run it through the algorithm again, and it comes up with a set of data for each intersection. It actually analyzes it by pattern. So whatever pattern is running out there, it'll actually run an analysis on each pattern that's running throughout the day. Once we select a pattern, we can go and look at each intersection within that's running that pattern along the arterial. And we can look at the predicted changes in delay. Sometimes it'll go up, sometimes it'll go down based upon the changes, but we have to look at the overall predicted reduction in delay to determine whether or not we're going to use it. So looking at intersection Highway 150 at Patton Creek here, you can see that we've got a pretty good analysis of reduction in delay for that intersection. We can look at the changes it makes, changes at offset, changes in cycle length, and changes in split for each phase. It also runs an analysis to show us the predicted arrivals of vehicles during the green band. So you can see the shift here. We've got much more vehicles in the green band now. So it runs all that analysis, and it does for each intersection. So if we decide that we want to run that, we can actually select it to be downloaded and run on that intersection. The next level is level 3, where instead of doing it manually and doing the manual selection on each intersection, we allow the software to do it on its own. Once we get comfortable with the fact that it's making the proper decisions and that the traffic is running efficiently, then we just bump it up to the next level and allow it to do it on a minute by minute basis instead of a weekly basis. The interface goes directly to the controller from the cloud. So once we start pulling data in, it goes to the SQL database, and from the SQL database to the cloud analyzes it, sends it back down to Centrax, where it's relayed back down to the intersection, and takes about maybe 30 seconds to send it down and get it running at the intersection. So this is what a real-time signal optimization looks like. Again, it's running on our arterial. This arterial actually has 7 intersections on it. It's actually, you can see that the data is being recorded once a minute. It's pulled up to the cloud, run through an optimization, and then the optimization within 1 to 3 minutes picks new cycle offset and splits for each intersection and downloads that back to the controller. So this is a little bit of history on how this all came about, or how it took place. We started in about 2013 with some timings that were developed by the consultant that they have on staff or on contract. They really needed to optimize their traffic patterns or their coordination patterns. They hadn't done it in a while, so we started with just upgrading their coordination patterns. From there, this was prior to any ATSPM analysis, but we ran traffic responsive on the original timings for about a year till about 2014. It had such an improvement that we started running traffic adaptive, Centrax adaptive on the Highway 59 for about the next 3 years. At that time, SPM, Ecolon's SPM system came out, and we started to migrate towards that from Centrax adaptive. The thing is, adaptives work really well, and the way they're supposed to handle traffic is to be able to maintain traffic over time, so that you don't have to go out and do as many timing studies. The adaptive control should maintain a good coordinated arterial and keep it running for several years, just by making the adjustments on a minute by minute basis. So for this, this is what we did for the step 1, where we implemented level 2. I don't have any accurate data from Gulf Shores anymore because it's been running adaptive for a year. And so I pulled this from another system we have in Tuscaloosa. I just wanted to show you the data that actually comes in. So we're running this on University Boulevard in Tuscaloosa. And this is actually analyzing over a week. So the analysis period was 1/5 to 1/12 of this year. It showed a drop in delay of 21 to 32% on each approach. So one's northbound, one's southbound, or eastbound, westbound in this case. So it goes through each of the patterns that is running at that intersection and does an analysis for each of the patterns. If I click on any one of the patterns, it'll actually bring up each individual intersection and show me the results for each individual intersection. If I click on each individual intersection, it'll actually show me the timings that it wants to use. It shows me the difference in cycle length, the difference in offset, difference in splits, and it shows where the arrivals of the vehicles should be. If I decide to accept those changes, I can actually apply it straight from here, and it'll send all the data to the controllers, and the controllers take effect almost immediately. If I come back within a week, the outcome here will show me how well it did over the last week. So it takes that timing and analyzes it, does another volume capacity and arrivals on green, and gives me a result. If I decide that it's not the results I want, I can actually revert it back to the original timings, and no harm, no foul. So once we did that for several months in Gulf Shores, we actually, again, were able to fine tune the adaptive system a little bit and get it back up to its maximum efficiency. It was still running Centrax adaptive, while we're doing the optimization on the corridor with SPMs. So once we fine-tuned it again after 4 years of running adaptive, we started to run the level 3 full-time or near real-time adaptive control. Gulf Shores actually has about 22 intersections running on 4 different arterials. We're going to concentrate on the north end here. It has the 7 intersections running adaptive control right now. So each intersection, the data gets uploaded once a minute. You can see down here, there's an analysis run about every 1 to 3, maybe 5 minutes. If it selects a new pattern and runs successfully, we'll get a green, but it can actually have a yellow warning where it's in transition or it hasn't gotten back into step yet. So as long as it's not in step, it can't run the analysis and we'll get a little bit of a warning on it. Again, a successful run will show changes in cycle length, changes in offset, and changes in splits where it makes the adjustments.
So try restarting it. Unplug the router. Wait till it's
Once it's sent down to the intersection, it'll run that until it picks new data to analyze. Here's basically how we set it up so that we know how it's going to make the changes that it decides. We look at the volume to capacity, and if it gets below 50%, we can decrease the cycle length by 10 seconds without going below 125 seconds. And then on the other way, if it goes above 75% volume to capacity, we can increase the cycle length by 10 seconds without going above 240. Maximum offset change, it's unbounded, so we can make any changes in offset that we want per cycle or per analysis. The direction priors for each phase, we can actually decide whether we're going to optimize northbound or southbound or optimize it equally. So generally, we're going to keep it equal. And then the splits, again, non-coordinated splits, we're going to adjust 5 seconds at the most. And coordinated phases, we're going to adjust 10 seconds at the most. We can decide if we want to lock an intersection down and not make an adjustment. So if we have, say, 2 arterials that are butting up against each other, we can lock those intersections so they stay the same, and every other intersection up and down the arterial makes adjustments so that we can maintain coordination between 2 arterials. And then finally, we look at some sequence of phase options, the data affinity, cycles to optimize, and cycles an offset period basically tell us how quick we're going to make the changes. We're going to analyze every cycle, and we're going to record the data for 15 minutes and go back and use it as hysteresis. So this one's optimizing pretty quickly. Show a few of the results. This top chart I ran from October 15, 2019, before we actually started doing any of the SPM analysis on it. You can see we were just running the reports. So I got an arrival on green report from one of the intersections on the north end. And you can see that we're running just barely, maybe 60% arrivals on green on average. And that's with the Centrax adaptive running and no optimization done. Over the last summer, we started running the optimizations. And even with the optimizations, we kept it right at about 60%. So from what we can tell, the adaptive was doing a good job at maintaining the coordinated patterns that we originally set out in 2013 and keeping them efficient. Running the optimization with SPMs didn't see much of an improvement, so we figured it was running pretty well. Moving that bottom chart to the top, you can see that's 922.20, so that's that chart with the level 2 optimizations running. We actually began implementing adaptive control about October last year. And so I ran a report from earlier this month, and you can see that the optimizations are up a little bit, maybe about 65%. Arrivals on green, so we got about a 5% improvement running the SPM optimization. So we're pretty happy with it. We think it's running and making good adjustments. So a 5% increase in adaptive is actually a significant amount, because if adaptive control is optimizing the intersection, then you're getting a 5% improvement. We think that's working very well. So, so basically what we saw is a slight improvement over the 4 years. No additional timing studies were performed since we began in 2013. And all the timing changes were recommended by in the last 4 months have been recommended by the SPM application and automatically changed at the controller level. So grabbing all that data and allowing the system to analyze it for you instead of analyzing it yourself is really helped out. So what does this mean to the city as far as allocating resources? This has been great for them. They haven't had to hire any extra personnel. They still have the one engineer on contract, and still have the 2 signal techs. But their roles have changed slightly. Instead of concentrating on keeping the controllers running, they're actually concentrating on maintaining accurate detection. I get reports almost daily that one of the technicians goes out and makes adjustments to the detection to make sure it stays 100% accurate. But the nice thing about it with the ATSPM that they're using, they're getting hotspots and concerns from each of the intersections. Again, from the hotspots down here, you can see signals with issues as well as detector concerns where there's no report of activity or an anomaly at an intersection. Again, you can also look at the hotspots on the map. So on a daily basis, technicians can go in there and look at these and decide where the most crucial data or most crucial attention needs to be made. They can run reports for arrivals on greens for an intersection where that might be a hot spot, and they can see if there's any reason to go out and look at. Sometimes arrivals on green will drop. There could be an accident, could be a construction area, but it allows them to at least analyze it and know whether or not they need to get out there and make any changes to the intersection. Here's an example of a delay at one intersection. It was running normal delays all day long and then popped up for about an hour. So probably consider that an accident or a construction that caused delays at an intersection. Not only does it show you the delays, but it also shows you which intersection or which detector was causing the delay. So if it actually had to be a detector change, you can go out there and make the change to the detector. Another hotspot that's really useful is split failures. These are indicators of how well the intersection is utilizing the phase timings. A split failure is a result of arrivals on green, arrivals on reds for each of the phases with advanced detection. Here you can see we're getting a lot of force offs on we got green occupancy ratio, and we're getting a lot of force off the greens here as well as down here. could mean that we may need to give a little more split time to phase 2 and 6. So let's look a little bit forward and see where the future is headed. Right now, about 30% of the agencies are using cloud-based technologies. They're either using Waze data, they're using ATSPM that's pushing it up to the clouds, some sort of data coming from cloud analysis. A lot of agencies are, again, moving away from client-server architecture. There's just too much data to manage, and it's too expensive to keep current data as well as historical data on traditional servers. So they're starting to push all that data up to the cloud where it's a little expensive to keep and maintain. Also, with all the web data becoming readily available, we're looking at crowdsourcing versus traditional connected vehicle. It's really amazing to see all these changes that are coming through and where the future is headed. Because it's all cloud-based already, it's really easy for other cloud systems to grab this data and pull it in and use it in their analysis. The only problem with the crowdsourcing data right now is the fact that there's only about 3 to 4% of the vehicles are actually transmitting the data. For systems to become effective using this crowdsourcing data, though, we're going to need to see about 10% of the vehicles actually transmitting their locations and speeds in order for it to be effective. That's about all I have on the system right now. I wanted to leave a little time for questions and answers at the end. So hopefully you guys have some questions. I'd be happy to answer it. The nice thing about this system is just because it's cloud-based, we can really keep up with the data that's coming in on a manageable level. And most of the customers that we have don't even know when we upgrade their system. It's automatically done over the web. And all the data exchange between the industries can also be managed in the future as it comes about. So we're looking forward to seeing what the next 5 years has to offer. We're expecting to see quite a bit of changes and quite a bit of new technology coming down the pipe. So keep posted and then we'll let you know. But anyway, does anybody have any questions?
Yeah, so this is Ayrton. Thanks, Mark, again for the presentation. Yeah, we have some questions rolling in. I have some questions for you too. So let's get started here with Adam from Franklin, Tennessee. So the first question is this open source to work on multiple ATC controller types manufacturers or just Econolite controllers?
No, this is open to any NTCIP controller that can store SPMs. We can pull the data. The system in Gulf Shores is actually running Centrax, and we have a service on their server that actually pulls the data out of the database and shoots it up to the cloud. We can put a similar service on anybody's server. We do have to get it somehow from the city's network to the cloud. So there has to be a service on one of the communication servers or a server that can access the controllers through the network. Then we can actually pull the controller directly and push it up to the web without actually having to have Centrax. So yes, we can do it on anybody's controller. Okay.
The next question, I actually have a similar question, and we can kind of bundle this together. So Adam is still asking, what is the transition period on average of controller? How many times per hour do you recommend changing splits offsets in a real-time mode? Example, transition periods?
That depends on the controller. I've seen controllers where it can take 10 minutes to transition. And I've seen controllers where it takes on average less than a minute. It's all based upon the controller's internal algorithm and how well the coordinator transitions. Some do it more efficiently than others, but for us, on average, it's a minute and a half, 2 minutes, so we can transition almost every five minutes.
Yeah, I agree with you. It depends on those algorithms. Most of the controllers have at least 4 or 5 algorithms, and you really need to take care of which one you're selecting there, because again, it can definitely make a difference. Like you mentioned, 10 minutes to a minute, 2 minutes. Of course, it depends on the size of the cycle also. But within that question, what I have to ask you, and I think we have some more here. I'll scroll down in just a minute. You mentioned about the SPM for transitions. So can you elaborate a little bit on that? What type of information you're getting? What I think I'm seeing here is you get some kind of information of within an hour or within a timing plan. What's the percentage of time that controller was running out of coordination in transition? Is that what we're saying here?
Yeah, let me, I'm going to switch my screen here for a second. I can actually bring up the SPM. So this is the actual SPM software for Gulf Shores. And the metrics.
Just wait a little bit. We're still not seeing it.
Okay.
We're still with the question. Yeah, there you go. All right.
Okay, so I could do a transition report. Let me do the transition here. I'll give it a little time to update. But it actually shows the total transition for yesterday. The date over here is 127, which is yesterday. So the total amount of time in transition that it took between all the plans that it's selected. And it shows the average add and the average subtract for each time it went into transition. So it gives you pretty extensive data.
Okay.
And this is the average daily for each signal, but added up, it adds up to a total of an hour and sentence.
Okay. Yeah, I've seen some systems that actually you have a diagram of your cycle length, and then that's color coded with the amount of time that was in transition. So I thought that was very, very intuitive of the way that they mentioned that. So there's another question here from Adam. So what's the benefit of an adaptive system if you need to also input signal performance measure optimizations into the adaptive system? Why both? Anything on that one?
Yeah, so we started with Centrex Adaptive, and we wanted to transition into the SPM or EDaptive. And in order to do some sort of before and after study, we did an analysis, but normally you don't have to run both. We just wanted to do a before and after analysis to show that it was actually performing as expected. So we started with the Centrex Adaptive. We ran the optimizer on it just to make sure we're still running optimized timings, and it continued to run Centrex Adaptive on that. Now, again, we can put optimized timings on it, but based upon the amount of traffic out there, weather, seasonal events, we still needed to have the adaptive control, even though we had optimized coordination patterns. And it ran very effectively on all days of the week, all days of the year.
Okay.
But to do the before and after study, we ran it through that process.
All right. We have another question here from Andrew. I think this is Andrew from West Virginia. Hey, Andrew. Can you discuss how well Centrex Adaptive and the SPM-based optimization each handled the sudden traffic influxes due to storms?
Yes. I don't have any charts to show you. I'd have to go back and find a day of a storm, but obviously they've had some hurricanes down there recently, and it was able to manage the mass exodus over the hurricanes, and as well as the fluctuations post-hurricane when people started coming back in, and with all the down trees and traffic, they were able to use the SPMs to find out where their detection was down and get it back up quickly and running again.
If you guys have more questions, please go ahead and add that to the chat box. I'm going to ask Mark one more here. That I'm always worried, Mark, and you know that. Again, that's the reason for the webinar here for us talking about this is, again, what changes in workforce? What is going to, how is the workflow of these agencies are going to change? If you have 11 signals here like Gulf Shores, or if you have 1,400 signals or 1,000 signals like Memphis have, for example. So I'm interested in that, on the difference that this is going to make on the number of people that need to work on it. I know you already mentioned that in Gulf Shores, it was not the case. I believe I understood correctly. You guys are running level 3, where is the adaptive, right?
Yes, yes.
So if you go to level 2, okay, if you go, and of course, these are going to have different levels of cost, I believe. But if you go to level 2, where you're running that pattern optimization, on your presentation, you mentioned that we ran the analysis. Who are we? Are you guys at Southern Lighting helping them with this? Or do we need, or are the technicians doing this and realizing that they need maybe to change the timing? So that's what I'm interested here. Who is doing that analysis of the system? Again, I understand that you have a level 3 there, but if we go to a level 2, to an agency that only wants to go to level 2, or maybe even level 1, what do you think is going to be the number of people that need to look at that data?
Yeah. Okay. So level 2 data, once the system is set up, it basically runs by itself. When I say we, I mean Econlight and the algorithms that they're running on the cloud. Okay. Most of what's done is presented in visual format. It's presented so that you can make an easy analysis on it, whether or not you're going to accept the data or not. So what you're going to see is you're going to be able to do a lot more with less people. Looking at the analysis and running it takes just a matter of maybe minutes to run through the data and decide whether or not you're going to apply it. It's the visual content is very easily analyzed, and it's a matter of minutes. So there's unfortunately, the cities aren't going to see a requirement to increase their personnel. They're going to be able to do, again, most of them are understaffed as it is. So this is really going to help them maintain their signals in a much more efficient manner at the cost of, a normal timing study for the year. Yeah. So it's really going to help them out. I don't see any increases being required for any agencies, only an improvement in productivity and efficiency.
All right, with that said, how do you see the role of consultants? Have you seen any of these systems that have been deployed that where consultants now have this availability of data? Does the agency is providing the data to the consultants, or how is that working?
Yeah, it's web-based, so it's really up to the users or the agency to determine whether or not the consultants can have access to that data. It's just a matter of setting up a login for the user, and then how that's managed. So if you still have consultants that you want to help you with it, it does take some management, a little bit to set it up, a little bit to make sure it's maintained. If there's a change in detection out in the field, either detection is added, moved, technologies change, whatever it is, and that's all got to be put back into the system so that it runs right. So I can see consultants playing a role in that, keeping it going for the agencies and making sure it's up to the latest effects out in the field.
Okay. All right. I don't see any more questions here. I'll throw one more at you. Maybe you can demonstrate here. You mentioned.
This is Bill. I have one.
Go ahead. Yeah, Bill.
The most common question that we get asked when we're doing systems, adaptive and things like that, what happens to the client or to the adaptive if we do not have detection in, let's say, advanced? What if we don't have stop bar, but we have advanced? What if we don't have per lane detection, but we have detection that covers 3 lanes on the advanced with one big detector? These are the questions that we get asked the most, and there is a big difference between one and the other. So I'd like to let Mark explain that one as well.
Yeah, we can do level 2 pretty well with minimal detection. As long as we have some setbacks, whether it's lane by lane or whether it's one input across all lanes, we can actually do pretty good analysis and improve some of the efficiency using level 2 optimization. But when it comes to level 3, adaptive control, really for it to work at its optimum level, it needs to have full lane by lane stop bar and lane by lane setbacks, at least on the main arterial. The more detection at the intersection, the better it's going to work. No doubt about it. And the best detection that we can find right now is above ground detection, whether it's video or radar, where we can get full lane by lane detection through an SDLC input. It's the most cost effective way to do it. It's easier to maintain and easier to make adjustments if there's lanes added or redesigned at the intersection.
All right, so I'll wait a little bit more for anyone that has any questions here. Let me ask you one thing. You also mentioned, I believe one of the reports that you guys have is on left turn gaps. Can you elaborate on how is that one being used?
Basically, it's analysis of, again, your coordination times, whether or not you really need to give all that time to your left turns. Let me see. Is that on ours? I think the left turn gaps, we use a different report. The left turn gap I actually found on ATSPM. That's one of their proprietary reports. So we don't have that, but we can actually run split monitor, and that gives us the same report.
Okay. All right. Yeah. I thought I've seen that one on the presentation.
Yeah. But yeah, that's one of the SPMs. But the split monitor will give us that same analysis where we can look at the program split versus the actual split that's being run and whether or not it's gapping out consistently. And we do that all in a whole intersection, just instead of just left turns.
All right. Anybody else have any other questions? And I have not seen anything else. I hope I didn't miss anything here on the chat box. If you want, you can just unmute yourself and ask questions here. But I'll wait a few more seconds here. If I don't see any more questions, I'll just like to say thank you very much, Mark and Bill, for putting this together. I think it worked fine. Again, if anybody on the call has questions, you have the presentation, you have emails, my email, you have emails for Mark and for Bill there. Again, thank you very much. Oh, here's one more from Andrew. So let's go through that. So traffic responsive has always been underutilized in part because the configurable parameters were a little vague and the volume occupancy data on which it was based wasn't easy to access. Do you think there will be, or have you seen, a renewed interest in TRP or something similar due to this new availability of data?
I do. I think this traffic responsive again is more like a level 2 SPM where you're actually analyzing and you're actually analyzing real-time traffic demand and running pre-programmed coordination patterns. So there's not much adaptability to it. And it still requires that over time, a traffic study be done to maintain that the coordination patterns are still efficient and effective. So using this will actually help analyze those traffic patterns to see if they're maintaining their efficiency. It would, if you decide that traffic responsive is the level you want to use, then this will definitely give you an analysis tool to see when those studies need to be redone. Most agencies, again, it's supposed to be 3 to 5 years. I've seen agencies that don't run the new timing studies for 10 years, and it's way out of whack by the time it's done.
Yeah.
So Having this in front of you and readily available will definitely allow you to watch your efficiencies and see when they start to slip. But going to that next level of adaptive, the biggest step is making sure that you have enough detection out there to run the adaptive.
All right, anybody else? We still have a little bit of time here if you're willing to ask a question.
And I can show you around the software if you want.
Yeah, if you have any questions on the software or any of the performance measures here, we'll be glad to show you. Okay. All right, Mark, I think I don't see any additional questions here. Again, thank you very much for participating. Thank you for joining us on the webinar. At the Traffic Signal Academy here at the UT Center for Transportation Research, we are planning to have more of these webinars throughout the year. And we'll let you know as soon as we have the next one available, we'll send you an email. So if anybody here on the call has not signed in the chat box, please put your name there. That's the way you're going to be able to get your PDAs. All right. And with that said, again, thank you very much, Mark and Bill, and we'll see you next time. Thanks a lot.
All right. Thank you.
Ayrton, this is Frank.
Hey, Frank.
Could you find out or ask if they're still online, who is Zoom user? That's all they've signed in with, and I can't identify them.
So I don't know if you guys heard that. We need to make sure that we get your name here. So if you have logged in as Zoom user, we just need to know who you are if you come back and ask us for a certificate. Okay, that's the only way we can provide a certificate for you. So again, if you want to identify yourself, just go ahead and put your name on the chat box, and that way we'll be able to send you a certificate. All right, Frank, thanks for logging in here. I think we have still a few folks that are logged in, but they're probably just forgot to log out maybe. So I'll end the presentation here. I'll end the recording, and whenever I get the link with the chat box, I'll send that your way, and I'll tabulate that information first, and then I'll send it your way. All right, thanks a lot, everybody.